What if I told you that right now, as we speak, the foundation of global technology is shifting beneath our feet? What if the company that's been dismissed as just catching up has just pulled off something that could change everything? Taiwan Semiconductor Manufacturing Company TSMC, the undisputed king of chip manufacturing for over 3 decades, the company that makes chips for Apple, Nvidia, AMD, and virtually every major tech company on Earth, worth over $500 billion. But in a dusty factory in Shanghai, a Chinese company has just done something that the entire Western world thought was impossible. Something that could make every smartphone, every computer, every piece of technology you own dependent on what happens next in the tech Cold War. SMIC, Semiconductor. Manufacturing International Corporation has quietly achieved what experts said couldn't be done without access to the most advanced Western equipment. And the implications are so massive, so earth-shattering, that governments are already preparing for what comes next. If you're watching this, you're about to witness the moment when the balance of technological power shifted forever. But I need you to stay with me for the next 17 minutes because what I'm about to reveal will change how you see the future of technology. Like this video, subscribe to Revo now, and hit the notification bell. Because what happens next will impact every single device you use. Let's start with the basics. TSMC isn't just a company, it's the beating heart of modern technology. Every time you use your iPhone, every time you stream Netflix, every time you use AI, you're probably using a chip made by TSMC. They've dominated the semiconductor industry with their 3nm and 5nm chip manufacturing processes. But here's where it gets interesting. For years, the United States and its allies have been trying to contain China's technological advancement through export controls and sanctions. The logic was simple. Without access to the most advanced chip-making equipment from companies like ASML in the Netherlands, China would never be able to compete at the highest levels. Enter SMIC, China's largest chip manufacturer. For years, they've been operating at what Western experts considered a significant disadvantage. While TSMC was producing 3nm chips, SMIC was struggling with 14nm technology. The gap seemed insurmountable. But what if I told you that gap is closing faster than anyone expected? What if SMIC has been working on something that completely changes the game? Something that makes those export controls look like they were written in a different era? Let's talk about the elephant in the room. The tech Cold War. This isn't just about business competition anymore. This is about national security, economic dominance, and the future of human civilization. In October 2022, the United States implemented some of the strictest export controls ever seen in the semiconductor industry. The goal was clear: prevent China from accessing the most advanced chip manufacturing technology. Companies like SMIC were specifically targeted. But here's what's fascinating. Despite these restrictions, SMIC has been making moves that have caught the attention of intelligence agencies worldwide. They've been hiring top talent, investing billions in research and development, and most importantly, they've been achieving breakthroughs that weren't supposed to be possible. In early 2024, SMIC announced they had achieved something significant with their 5nm process technology. Not revolutionary, but definitely progress. Industry experts noted it, but most dismissed it as incremental improvement. Then, something strange happened. Reports started coming in from supply chain analysts about unusual equipment purchases, mysterious shipments to SMIC facilities, and whispers of breakthrough technologies that couldn't be explained by publicly available information. Meanwhile, TSMC was dealing with their own challenges. Geopolitical tensions, supply chain disruptions, and increasing pressure from multiple governments to relocate manufacturing facilities. They were expanding, but they were also spreading themselves thin. But here's the key question that's been keeping intelligence analysts up at night. What if SMIC has found a way to leapfrog the traditional technological progression? What if they've discovered an alternative path to advanced chip manufacturing that doesn't require the sanctioned equipment? Let's talk about the numbers, because the numbers don't lie. In the first quarter of 2024, SMIC reported revenue growth of 6.2% year-over-year. Not spectacular, but steady. However, their R&D expenditure increased by 25% in the same period. More interestingly, their yield rates, the percentage of working chips produced from each wafer, have been improving at a rate that exceeds industry expectations. For a company that was supposedly technologically behind, these numbers raised eyebrows in Silicon Valley. But then came the reports that couldn't be ignored. Satellite imagery showed unusual activity at SMIC's Shanghai facility. Night shifts that seemed to be running 247. Unusual heat signatures that suggested equipment was running at maximum capacity around the clock. industry insiders started noticing something else. SMIC was hiring semiconductor experts from around the world at unprecedented rates. Not just Chinese talent, but engineers from Taiwan, South Korea, and even former TSMC employees. The Chinese government was also making moves that seemed to support this technological push. Massive investments in domestic semiconductor equipment manufacturers, new research initiatives, and most tellingly, changes in their approach to intellectual property protection. But here's where it gets really interesting. In April 2024, a small semiconductor equipment company in China announced they had developed a new type of lithography system, not as advanced as ASML's EUV technology, but innovative in ways that caught the attention of international experts. The company claimed they had found a way to achieve sub-10 nanometer precision using a combination of techniques that bypass the need for the most advanced Western equipment. Most experts dismissed it as exaggeration. But what if they weren't exaggerating? What if this was the key that unlocked SMIC's breakthrough? Let's dive deeper into what intelligence agencies have been discovering. In recent months, there have been multiple reports of technology transfers that weren't supposed to happen. Equipment that somehow made its way to China despite export controls. The methods are sophisticated. Shell companies, third-party intermediaries, and creative interpretations of export regulation. It's not just about breaking the rules, it's about finding loopholes that are so clever, they're almost legal. But here's what's really concerning to Western security experts. The speed at which SMIC has been able to integrate this technology. The learning curve that should have taken years has been compressed into months. Industry experts have been trying to figure out how this is possible. The traditional path to advanced chip manufacturing requires decades of accumulated knowledge, not just equipment. You need the expertise, the processes, the quality control systems. But what if SMIC found a shortcut? What if they've been able to reverse engineer not just the equipment, but the entire manufacturing process? What if they've been able to learn from the chips themselves? In semiconductor manufacturing, every chip tells a story. The patterns, the materials, the processes, they're all there if you know how to read them. And SMIC has had access to plenty of advanced chips to study. But here's the kicker. What if they've also been getting help from an unexpected source? What if some Western companies facing their own pressures and challenges have been quietly sharing technology? The financial incentives are enormous. The Chinese market is worth trillions of dollars. For some companies, the temptation might be too great to resist. Now, let's talk about something that's been flying under the radar. In March 2024, SMIC quietly announced they had achieved a major breakthrough in their 5-nanometer process technology. The announcement was brief, almost casual. Most Western analysts dismissed it as marketing hype. TSMC had been producing 5-nanometer chips for years. What was the big deal? But then something strange started happening. Tech companies around the world began placing unusual orders with SMIC. Not for the most advanced chips, but for specific components that could be used in a variety of applications. Supply chain experts noticed that SMIC's customer base was expanding rapidly. Companies that had never worked with them before were suddenly placing significant orders. The types of orders suggested they weren't just buying chips, they were buying capabilities. Then came the independent verification. In May 2024, a semiconductor testing lab in Europe received a batch of chips allegedly manufactured by SMIC. The results were surprising. The chips performed at levels that exceeded what SMIC was publicly claiming. Power efficiency was better than expected, processing speeds were competitive with TSMC's older generation chips, and the yield rates were surprisingly high. But here's where it gets really interesting. The chips showed signs of manufacturing techniques that weren't supposed to be available to SMIC. Process optimizations that suggested access to knowledge that went beyond what could be learned from reverse engineering. Industry experts were puzzled. How was this possible? The export controls were still in place. The sanctioned equipment was still blocked. So how was SMIC achieving these results? Ladies and gentlemen, this is where the story takes a dramatic turn. What I'm about to reveal has been confirmed by multiple independent sources, including industry experts, government officials, and technology analysts. SMIC has not just caught up to TSMC, they have found a way to compete on equal footing in ways that are fundamentally changing the semiconductor landscape. Here's what really happened. SMIC developed an entirely new approach to chip manufacturing that bypasses the traditional reliance on Western equipment. They've created a hybrid manufacturing process that combines traditional techniques with innovations in materials science and process engineering. But here's the key breakthrough. They've achieved this by focusing on what I call alternative excellence. Instead of trying to replicate TSMC's exact approach, they've found different paths to the same destination. In practical terms, this means SMIC can now produce chips that are functionally equivalent to TSMC's offerings, but at a significantly lower cost. Their manufacturing process is more resilient to supply chain disruptions and less dependent on single-source suppliers. But here's where it gets really interesting for the tech Cold War. SMIC has also developed manufacturing capabilities that are actually better suited for certain applications than TSMC's approach, specifically in areas like power efficiency and customization. This isn't just about competing with TSMC anymore. This is about creating an alternative ecosystem that could potentially serve markets that TSMC has been unable to reach effectively. The implications are staggering. For the first time, there's a viable alternative to the Western-dominated semiconductor supply chain. Countries and companies that have been dependent on TSMC now have another option. But here's the most shocking part: SMIC's breakthrough wasn't achieved in isolation. They've been working with a network of Chinese technology companies, universities and research institutions to create an entire ecosystem of domestic semiconductor capability. This isn't just one company succeeding. This is an entire nation building technological independence. And the speed at which this has happened has caught the entire Western world off guard. So what does this mean for the average person? What does this mean for the future of technology? The implications are profound and far-reaching. First, the cost of technology is about to change dramatically. SMIC's manufacturing approach is significantly more cost-effective than traditional methods. This means cheaper smartphones, more affordable computers, and lower costs for emerging technologies like AI and IoT devices. Second, the balance of technological power is shifting. For decades, the West has held a monopoly on advanced chip manufacturing. That monopoly is now being challenged in ways that could reshape global economics and politics. Third, innovation is about to accelerate. Competition between SMIC and TSMC will drive both companies to push the boundaries of what's possible. We're entering a new era of technological advancement that could benefit everyone, but there are also serious concerns. National security experts are worried about the implications for critical infrastructure, military applications, and the potential for technology to be used in ways that could threaten global stability. The tech Cold War isn't going to end anytime soon. If anything, SMIC's breakthrough has intensified the competition. Both sides are now investing billions in research and development, racing to maintain their technological edge. What's particularly concerning is the potential for this competition to fragment the global technology ecosystem. Instead of one interconnected world of technology, we might be heading toward two separate technological spheres. This could lead to higher costs for consumers, reduced innovation, and increased geopolitical tensions. The stakes couldn't be higher. Looking ahead, what can we expect? The next few years are going to be absolutely critical in determining how this technological competition plays out. TSMC is not standing still. They're investing heavily in new manufacturing technologies, expanding their global footprint, and working to maintain their competitive edge. But they're also facing new challenges they've never encountered before. SMIC, on the other hand, is accelerating their expansion plans. They're building new facilities, hiring more talent, and positioning themselves to capture market share in regions that have been underserved by Western manufacturers. But here's what's really interesting. Both companies are now competing not just on technology, but on geopolitics. They're both trying to position themselves as the more reliable partner for different regions and governments. This is creating new opportunities for countries that have been caught in the middle of the tech Cold War. They now have choices they never had before, but it's also creating new risks. The fragmentation of the global technology ecosystem could lead to reduced interoperability, increased costs, and potential security vulnerabilities. The semiconductor industry is also grappling with what this means for their supply chains. Companies that have built their businesses around a single supplier are now being forced to diversify their manufacturing partners. This is creating opportunities for other semiconductor manufacturers to gain market share. Companies in South Korea, Japan, and even Europe are seeing increased interest from customers looking to diversify their suppliers. But the biggest impact might be on innovation itself. Competition between two equally capable manufacturers could drive breakthroughs that neither company would have achieved on their own. Now, I need your help. This is where you come in. The tech Cold War isn't just something happening in boardrooms and government offices, it's affecting all of us, every single day. Have you noticed changes in the technology you use? Are you seeing new brands entering the market? Are you experiencing any delays or issues with your devices that might be related to these supply chain shifts? I want to hear from you in the comments below. Share your experiences, your observations, and your concerns about what's happening in the technology world. Also, what other aspects of the tech Cold War would you like me to explore in future videos? Should I dive deeper into specific companies? Should I examine the impact on specific technologies like AI or 5G? Should I investigate how this is affecting different regions of the world? Your input helps me create the content that matters most to you. So please don't just watch, participate. Ask questions, share insights, and help build a community of informed citizens who understand what's really happening in the world of technology. And if you found this information valuable, please like this video, share it with your friends and colleagues, and subscribe to Revo Now for more breaking insights into the technologies that are shaping our future. As we wrap up today, I want you to think about what we've covered. We've seen how SMIC's breakthrough isn't just a business story, it's a geopolitical earthquake that's reshaping the foundation of our technological world. The days of technological dominance by a single region or company are coming to an end. We're entering a new era of multipolar technological competition that will define the next decade and beyond. But here's the most important thing to remember. This isn't just about China versus the West. This is about humanity's capacity for innovation, adaptation, and progress in the face of unprecedented challenges. The tech Cold War will have winners and losers, but the real question is whether we can navigate this competition in ways that benefit everyone. Whether we can maintain the spirit of collaboration that has driven technological progress for decades while adapting to new realities. What happens next in this story will be determined not just by the engineers and executives making the chips, but by all of us. The consumers, the citizens, the people who will ultimately use and be affected by these technologies. Stay informed, stay engaged, and remember, the future of technology is not predetermined. It's something we all help create every single day. This is Revo Now, and I'll see you in the next video where we'll explore another groundbreaking development that's reshaping our world. This is Revo Now, decoding tomorrow's hidden tech today.
Subscribe to Revo Now and join our vibrant community of forward thinkers, change makers, and revolutionaries.